Laplace transform. If f of t is a real valued function defined for t greater than or equal to 0, then Laplace transform of f of t is denoted by capital L of f of t and is given by the integration 0 to infinity e power minus st f of t dt. Here we can note the integrand is made of two parameters s and t, and we are integrating this with respect to t with constant limits 0 and infinity. So if this integral exists, then it will be a function of s alone, and we denote it as capital F of s. And from now onwards, if I say L of some function f of t equal to f of s, that says Laplace transform of the function f of t exists and it is equal to capital F of s. Laplace transform transforms the problem from t comma f of t coordinate system to s comma f of s coordinate system, where we find the solution for that problem and we will write the solution for the problem which is posed with the help of inverse Laplace transform. Linearity property of Laplace transform. It speaks about two things. Point number one, Laplace of constant into f of t can be written as constant into Laplace of f of t. That is, constant can be taken outside the Laplace operator. Point number two, Laplace of f of t plus g of t is equal to Laplace of f of t plus Laplace of g of t. That is, Laplace of sum of two functions can be written as sum of Laplace of the individual functions. We can combine these two properties together to write a single statement, that is Laplace of constant into f of t plus constant into g of t is equal to constant a into L of f of t plus b into L of g of t. Laplace transform of elementary functions. We need the following formulae for the whole chapter. We can derive these by using the definition of Laplace transform. In the place of f of t, if I substitute 1 and if I integrate this with respect to t between the limits 0 and infinity, we are going to end up with 1 by s. In the same lines, if I replace f of t by e power at and if we just integrate that expression with respect to t between limits 0 and infinity, we will end up with 1 by s minus e. In the same lines, the definition of Laplace transform, we can derive all these formulae. Laplace of 1 is 1 by s. Laplace of e power at, exponential function. Here we need to look for this a, and this a will decide my output. It's 1 by s minus a. So Laplace of cos hyperbolic at. This will say like s by s square minus a square is your answer. L of sin hyperbolic at is given by a by s square minus a square. L of cos at is s by s square plus a square. L of sin at is a by s square plus a square. If we just look at these four formulae, we can note these two are similar These two are similar, and the difference is here we have got the negative sign. With respect to hyperbolic functions, we have negative sign in the denominator. In these two cases, positive sign will be there. Here the variable s comes to the numerator. Here the constant a will be present in the numerator. If we come to this is Laplace transform of a polynomial. It's t power n. Here n cannot take negative integer. It's given by gamma of n plus 1 divided by s power n plus 1. Further, Laplace of t power n, if n is positive integer, it is given by n factorial upon s power n plus 1. Okay, this is the general formula. This becomes a particular case. You can employ this directly once if n is positive integer. Now, let me discuss problems which uses above formulae. In this problem, we have Laplace transform of sum of these functions. Linearity property holds good, so I can rewrite this one as L of first term. Here e square is a constant. It's free from t. It's a constant. Let me write it outside the Laplace operator. So it is Laplace of 1 plus Laplace of e power minus 3t plus Laplace of cos 3t plus Laplace of sine hyperbolic 3t plus Laplace of t power 3. It's e square into Laplace of 1 is 1 by s plus L of e power minus 3t. The role of a is played by minus 3. So it's 1 upon s minus of minus 3. That becomes s plus 3 plus L of cos 3t. The role of a is played by 3. So it is s upon s square plus 3 square, which is 9 plus L of sine hyperbolic 3t. So it is 3 upon s square minus 3 square plus L of t power n, where n is positive integer. So it is 3 factorial upon s power 3 plus 1, which is 4. So 3 factorial becomes 6. So it is 6 upon s power 4. And there is no need to simplify it further. We can stop at this point. So this is once again what? This is Laplace of sum of two functions. So by applying linearity property, this is Laplace of first function plus Laplace of second function. So these two functions are not in standard form. We are making use of the idea of a power x is equal to e power log a into x for this 2 power t. So as a result, this becomes Laplace transform of e power log 2 multiplied to t. We know cos hyperbolic x is given by e power x plus e power minus x divided by 2. With the help of this can be rewritten as it's e power 3t plus 2 plus e power minus of 3t plus 2 divided by 2. This is equal to, this is 1 upon s minus, the role of a is played by log 2. I'll just write the log 2 in this place. Plus, this is 1 by 2 is constant. Let me just keep it outside. This is not in the standard form. Standard form is e power at. So this can be rewritten as a power m plus n is a power m into a power n. With the help of this can be rewritten as e power 2 into Laplace of e power 3t plus here e power minus 3t into e power minus 2, that gives e power minus 2 into Laplace of e power minus 3t. So this is 1 upon s minus log 2 plus half times e square into Laplace of e power 3t is 1 by s minus 3 plus e power minus 2. Laplace of e power minus 3t is 1 by s minus of minus 3, that is s plus 3. Next one is L of sine hyperbolic square of 2t plus 1. Not in standard form. Sine hyperbolic 2t plus 1. I need to put it in exponential form. What is sine hyperbolic x? It's given by e power x minus e power minus x divided by 2. With the help of this becomes e power 2t plus 1 minus e power minus 2t plus 1 by 2. Let me square on both sides. Sine hyperbolic square of 2t plus 1 is equal to, it is this square of this whole expression. Let me just take this denominator out with the square. It becomes 1 by 4. Square of this a minus b, that gives a square plus b square minus 2ab e power 2t plus 1 into e power minus 2t minus 1. This is 1 by 4 times, this is, we know a power m whole power n is a power m into n, that's e power 2 2s of 4 t plus 2 plus e power minus 4t minus 2 minus 2 times e power plus 2t minus 2t plus 1 minus 1, that's e power 0. So what we have now, it's 1 by 4 times, this is e square, it's a constant, into e power 4t, it's plus e power minus 2 constant into e power minus 4t minus, it is just 2. I just wanted Laplace of this. Now let me take the Laplace. So Laplace of sine hyperbolic square of 2t plus 1 is given by 1 by 4 is a constant, e power 2, it's a constant, Laplace of e power 4t is 1 by s minus 4 plus e power minus 2 into Laplace of e power minus 4t is 1 by s plus 4 minus 2 into 2 is a constant into Laplace of 1 is 1 by s. That's all. This is Laplace of sum of two functions. So it is Laplace of cos square 3t plus Laplace of sine cube t. To find Laplace of these two, we need to remember these two formulas. Cos square theta is 1 plus cos 2 theta divided by 2. Sine cube theta equal to 1 by 4 times 3 sine theta minus sine 3 theta. Now let me substitute these two here. Cos square 3t becomes 1 plus cos 2 3s are 6t upon 2. Let's close the bracket, plus L of, this is 1 by 4 times 3 sine t minus sine 3t. This is equal to 1 by 2 is a constant. Laplace of 1 is 1 by s, plus L of cos 60 is s by s square plus 36, plus 1 by 4 is a constant. 3 times L of sin t is 1 by s square plus 1 minus L of sin 3t is 3 divided by s square plus 3 square, that is 9. That's all. In this case, I need to know sin A, sin B formula, which is half times cos of A minus B minus cos of A plus B. So this is Laplace of 1 by 2 times cos of 2t minus 5t, that is cos of minus 3t. We know cos of minus theta is cos theta. So it is cos of minus 3t becomes just cos 3t minus cos of 2t plus 5t, that is cos 7t. So 1 by 2 is a constant. So Laplace of cos 3t is s by s square plus 3 square, which is 9, minus s upon s square plus 7 square, which is 49. L of t power 5 by 2 plus t power minus 5 by 2. This is Laplace of t power 5 by 2 plus Laplace of t power minus 5 by 2. This is equal to, this is L of t power n. N is not an integer. So it is gamma of n plus 1. It's 5 by 2 plus 1 upon s power 5 by 2 plus 1 plus gamma of minus 5 by 2 plus 1 upon s power minus 5 by 2 plus 1. This is equal to gamma of 7 by 2 upon s power 7 by 2 plus gamma of minus 3 by 2 divided by s power minus 3 by 2. Now let me write the value of gamma of 7 by 2. Its value is what? 5 by 2 into 3 by 2 into 1 by 2 square root pi is whole thing divided by s power 7 by 2 plus gamma of minus 3 by 2, that's given by square root pi upon minus 3 by 2 into minus 1 by 2 into s power minus 3 by 2. This is equal to, now let me just simplify this. 5 3 is a 15, 15 square root pi upon, it is 2 cube, so it is 8 s power 7 by 2. And here minus into minus plus, 2 2s are 4, that 4 comes to the numerator. It's 4 square root pi upon 3 will remain in the denominator, 3 into s power minus 3 by 2. Problem number 7. Laplace of square root t plus 1 by square root t whole cube. Here first we need to know a plus b whole cube formula. That's a cube plus b cube plus 3 a square b plus 3a b square. So root t plus 1 by root t whole cube is equal to a cube, that is root t cube plus 1 by root t plus 1 by root t whole cube plus 3 root t square into 1 by root t plus 3 root t into 1 by root t whole square. This is equal to, let me put it in a standard form. Root t is nothing but t power 1 by 2 raised with the power 3, so it becomes t power 3 by 2. This is nothing but, if I just take this to the numerator, it is t power minus 1 by 2 whole power 3, so it becomes t power minus 3 by 2 plus 3, square root and square cancels, t into 1 by root t, that is t power 1 minus 1 by 2, it becomes t power 1 by 2 plus 3, here this once again square root and square cancels, take t to the numerator, t power 1 by 2 minus 1, that is t power minus 1 by 2. Now apply the Laplace on this. So Laplace of square root t plus 1 by square root t whole cube is equal to Laplace of these individual functions, it is Laplace of t power 3 by 2 plus Laplace of t power minus 3 by 2 plus 3 times Laplace of t power 1 by 2 plus 3 times Laplace of t power minus 1 by 2. This is equal to Laplace of t power n should be used in each of this, which is given by gamma of n plus 1 divided by s power n plus 1. So the first one is gamma of 5 by 2 upon s power 5 by 2 plus, this is gamma of minus 1 by 2 divided by s power minus 1 by 2 plus 3 times gamma of 3 by 2 by s power 3 by 2 plus, this is 3 times gamma of half divided by s power half. Now let me write the values of these gamma functions. It is 3 by 2 into 1 by 2 square root pi upon s power 5 by 2 plus, it is square root pi upon minus 1 by 2 into s power minus 1 by 2 plus 3 times, this is 1 by 2 into square root pi divided by s power 3 by 2 plus 3 into gamma of 1 by 2 is square root pi divided by s power 1 by 2. So the answer is 3 square root pi divided by s power 5 by 2 Okay, plus into minus, that becomes minus. 2 comes to the numerator, it is 2 square root pi divided by s power minus 1 by 2 plus 3 square root pi divided by 2s power 3 by 2 plus 3 square root pi divided by s power 1 by 2.